Okay, what is it? 2:27. It's almost March. Hard to believe with the weather, huh? Okay, so our objective today, we're still factoring. We're still factoring trinomials, but these have special names. So we're factoring what we call difference of squares and we're factoring what we call perfect square trinomials. A lot of fancy words. Let's see if we can make the words make sense, okay? A lot of fancy words, okay? Okay, difference. In math, difference means subtract, right? So check out example 1. You see the subtract? Okay, difference. So, I mean, that makes sense. Of squares. That's a square, x squared. And that 9 is actually a square too. It's 3 squared. You guys see that? So I've got a square minus a square, difference of squares. 2, difference of squares. That's a perfect square minus another perfect square, 5 squared, right? So it's a difference of squares, okay? Look at 3. It's a perfect square. It's a square minus a square, right? So it's a difference of squares. That's where the name comes in. Look at number 4. It's a square, 3 squared, 3 and 5, right? So it really is a square term minus another square. So that's where the word difference of squares comes from, okay? We'll do the perfect square trinomials over here next, okay? So it's super easy. Now before I do it, let's rewrite it. X squared plus 0x minus 9. Okay? Now we're not going to ever write the 0x again. But there is, in a sense, a 0x. So then let me ask you an easy question. What are the multiples of negative 3 that would add up to 0? What are the multiples of negative 9?
Oh, negative 3 and 3.
That's it. You want to see how easy this is? It's just going to be a x plus 3, x minus 3. That's it.
So you're just trying to cancel that to get 0?
Absolutely. Absolutely. Because when you do your double smiley, what's your double smiley going to make?
9. It's going to
Zero.
those two out.
Right? And you get the 0x, right? And of course, it'd be silly to write the 0x. You guys agree? But we know it's there. So the middle term is 0. That's why you need the positive 3 and negative 3. When you add them together, it makes the 0, right? That is the answer. Isn't that easy? Okay. How about example 2? Okay. Well, let's start with 2x. 2x. You okay with that? What times what makes 25?
5.
But let's go plus 5 and a minus 5. Okay, is it right? Well, first of all, what's the middle term? What's the middle term? What's the middle term? 0 degree? Middle term 0. So let's check it out. Let's do our double smiley. What do we get?
0.
10x. Negative 10x is 0. Pretty soon you're going to stop doing this. You're going to recognize what they are, and you're going to just do it, okay? Okay, how about example 3? What do you think? Am I going too fast, by the way? I'm hoping you guys say, Mr. Davies, this is easy. Yesterday was the hard stuff, okay? What do you think? It's got to be 4 because it said squares, right? So it's got to be 4x. 4x, okay, because it's the square. And then what? And then what? Plus 5y minus 5y. And if you want to check your double smiley, 20xy minus 20xy cancels and makes 0, right? Because your middle term is 0. Thumbs up? Okay, good. All right. Okay, now 4. Let's factor it before we solve it, okay? So, if we factor it, what are we going to get?
3x minus 5 is 3x plus 5.
Yep. Yep, you guys agree? Yeah, Arjun.
2 5s keep getting these other numbers.
How do these two 5s?
I'm not getting this.
No, okay, so what times what makes 25?
5.
5 times 5.
Right. And then what times what makes a 9x squared? 3x, no 3x, right?
The other one now.
This one here. That one here? Okay. 16x squared, you agree? Negative 25y squared, right? 5 times 5, right? And y times y, okay? And then there really is a 0 term in here, but it's invisible because this would make a negative 20 and a positive 20, and they'd cancel each other. And then the 0 term is there, but it's invisible, right?
So these are going with the 0 term. I'm not getting.
Yeah, yeah. So what we're going to do is just take the square roots of these, the square roots of these. Square root of 16 is 4 and 4. Square root of 25 is 5 and 5. Okay, so you ready? What's the square root of 9? 3 and 3. What's the square root of 25? 5 and 5. Yeah, it's that easy. But we're not done with this one, are we? We're not done with this one, are we? What do I need to do? What do I need? I'm not done with this one. What do I need to do?
Make it to 0.
Okay, do our mini equations, right? Right, mini equations. So let's go 3x minus 5 equals 0. 3x plus 5 equals 0, right? How many answers? Always 2, right? Always 2. So check it out. Plus 5 plus 5. 3x equals 5, right? Divide by 3, divide by 3. One answer is 5/3, or 1 2/3, or 1.66666, whatever. I like 5/3 better, right? Second answer, minus 5, right? 3x equals negative 5, right? Divide by 3, divide by 3. The other answer is negative 5/3, okay?
It's like
Or, now, here's another way to write it, okay? I like this. These are great. Or you can write this as plus or minus 5/3. That's another way to write this because it writes them both at the same time. See, I got the plus or minus because I have a negative and a positive. It's a faster way to write both answers, okay? You saw that last year, right? Yep. Okay, turn the page. Nina's already cruising along. Okay, now, these are called perfect square trinomials. Okay, now I'm going to show you why they're called perfect square trinomials. What we're going to get as an answer is we're going to get an answer of sum a plus b quantity squared. Those are the kind of answers we're going to get. Mr. Hoya could teach this. He's a mathematical genius.
Where is it?
Perfect square trinomials.
X plus 3 squared.
Yep, exactly. Yep. Let's see if you guys can see this right. Okay, so you ready? Parentheses, 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 right? This should be easy. Should be easy, okay? So tell me, what times what makes 9 that also adds up to 6?
If you get a chance.
Oh, okay.
Parents called.
Yeah, yeah, okay, that's right, yeah. Yep. Remind me, okay?
And then Celeste Dad's here. So.
Okay, you guys remind me. Caleb's homework. I forget things because I'm old, okay? All right, thanks. You guys remind me, won't you? Okay, so Miss Davies, get Caleb's homework. All right, there you go. Okay, so how about, what do you guys got? X, what did I hear? X plus 3, x plus 3, right? Because 3 times 3 makes 9, and 3 plus 3 is 6. Now this is very unique because you get the x plus 3, you get the same thing twice, right? So we can rewrite this as x plus 3 squared. Both answers are the same. Both answers are correct. This is just a different version of it because the squared means twice times itself, okay? Yes, R2.
So it just means those two are the same.
That's all. So if I had, let's go 7 squared. Means 7 times 7, right? Or 7 times 7 is 7 squared. So x plus 3 times x plus 3 is the same thing as x plus 3 squared. Okay, how about 6? What do you think about 6?
5.
X minus 5 squared.
You're way ahead of me. X minus 5, x minus 5. You guys agree? Or x minus 5 quantity squared. Either answer is fine. I will take either answer. Okay, got it? Either answer is fine. Okay, I like this way because it's kind of cool, right?
Yeah.
But you know. Okay, now what about example 7?
2x plus 5 squared.
2x plus 5 squared.
Okay, yes, 2x, right? You can't 2x. Yes, we're going to get there. Nice job, guys. Plus 5, plus 5. Now, where's the 20x? Where's the 20x?
The 2x times the 5 would be the double final.
You guys see it? 10x. Or, so this is correct, but a better way to write it is 2x plus 5 quantity squared. Today's easy. You guys agree? Yesterday was the hard stuff, right?
I like this.
Yeah, heck yeah, me too.
Get rid of that other.